Myself, Dharmen Kumar, and I'm going to say about preliminary geological evaluation of Vajri landslide, which is one of the most important landslide on Yamunotri highway and affecting national highway, especially in the rainy period. Next. So, scope and objectives. Basically, to evaluate the landslide affected area, recording all the geological informations and probable causative factors, suggest the site-specific remedial measures for restoration of slide affected area, and keeping in view the vulnerability and magnitude of the slide to explore the other possibility for long-term remedial measures as well as alternative measures. Next. This is the slide, which is about 30 or 35 kilometer upstream from Badkot area, which is one of the township between Vajri, one of the villages, and Saina Chatti. This is the Yamuna river. This valley is the Yamuna river valley. And this slide is one of the old slide, which is probably initiated in 2003 as per the locals, and reactivating after every year after that, especially in the rain period. And the reoccurrence of slide in 2017, and which has been affected or impacted about 300 meter of the stretch of that NH 94. And again in 2018, the slide has been reactivated, and still think that slide has blocked that road. Next. Regional geological setup. Basically the area is exposes rocks of the central crystalline, Devan rocks of the Devan group, Gadwal group, as well as Murar Chakrata, and the quaternary deposits along the river. And the slide area is slide is basically located in the rocks of central crystalline, which is the locally means formation is known as Vajri formation, which is basically comprised of the gneisses, variants of gneisses, as well as schist in between. Next. The geological evaluation. We have been evaluated that the width of the slide of about 100 meter in the ground portion, 300 meter at road level, and the length is about more than 900 meter, and height is about more than 650 meter. And the depth of the slide near the road is more than 5 meter, or in the crown portion it is probably somewhere 0 or somewhere 5, or even in somewhere more than that 5 meter. But it is not possible to go there at that time during the study, because that study has been done in the rain period. So there is no approach road or no approach way or path to go here. Basically the source area, this is the source area. Source area is located above EL 2085, and the affected zone means disturbed zone is about 300 to 400 meter, not all this area. Basically here there is a disturbance, and you can see in the photographs. This is the Google image before 2016, then 2017 and 2018. The increase or means activities of the change in the morphology of the landslide, how it is in 18 and how it is in 2017, and what is the condition in 2016. Next. This is the land use land cover map. Basically here there is a this green color is sparse vegetation. This is the barren land, and the yellow color is the cultivated land, the river Yamuna. Now here there is a main scarp, which is about 450 meter elevation, and this photo is taken in 2017. This one is after 1 year, 2018. The changes, basically the changes is here below the main scarp. You can see here there is a cracks, longitudinal cracks, even some transverse cracks. Here another scar which is developed in 2017. But in 2016 there is nothing. But you can see the impression of that main scar here. Means there is something that is happening. In 2000, started happening in 2016. But it has been activated or completely activated or active in 2017 and 18. And now this mass has been already displaced or has fallen down in 2018. Next. This site geology, basically the area is rugged and highly dissected, steep slopes, and some local nala or first order nala is there, but during the study the wet condition has been observed. The exposed rock mass is the means rock of central crystalline, as I already explained. There is one major plain which is MCT passing, which is near. As per the map, the MCT is about 2.5 and 3 kilometers downstream from the location of the slide. And the joint data has been collected, and 3 to 4 joint sets have been collected during the preliminary study. Next. Now, number of things are there in this slide, but I want to start from the rain data. I have plotted this rain data almost 5 years, from 2013 to 2017, and the data of 4 months, July, means June, July, August, and September of 2018. The source is IMD sites, and I have seen that there is a maximum rainfall in the from June to July. Most of the means intensity of rainfall in this month, and again the slide is happening in same period. So there is means some rainfall is one of the factor which is initiating the slide. And I have prepared one section, that is geological section, based on the this map from A to B, and I have seen that there is a means steep slope. On an average, the steep slope is about 50 degree, means about 50 degree on average. And I have plotted the joints with relation to the slope, and I have seen that there is a possibility of means planar failure, as well as formation of wedges, as well as topplings, but not each and everywhere. But if I have analyzed this data at 80 degree, because I have during the study I have collected some data of slope where we have got the slope angle is more than 80 degree or 80 degree. So again I have seen that there is a possibility of planar waves and all the toppling, but not an everywhere. I have seen this collected data from the roadsides, and I have seen there. Next, the probable cause of slope failure. Basically, the slide is, of course, the massive slide, which is about, the length is about more than 900 meter, and the rock slope is steep. That is one of the major cause of the stability in Himalayan terrain, and even that slope is looking like hummocky, which is one of the indication. As well as the slide has been triggered by the incident heavy rainfall during the monsoon period, highly jointed and sheared or shattered rock mass in the crown area, which has been, I have already shown in the photos, longitudinal cracks, as well as the transverse cracks, which is basically in the, present in the crown portion, and which is acting as a conduit for water. That because of the percolation of water, it is probably the reduction in the shear strength of rock mass or highly shattered rock mass, which is acting as like a soil. And one major discontinuity plane or regional discontinuity plane, which is also means nearby the area, which is affecting the rock mass in that area, as well as the stereo plots or kinematic analysis shows that there is a formation of wedges, planar and toppling. These are the probable causes. Next, the conclusion. Seeing the massiveness of this slide, I think there is no means the temporary or short-term remedial measures is not effective for that. So in that time period, we have suggested that the realignment of that road, and we have seen that there is another road in the another bank which can be used for that time, and suggested that for using that road in that period. Apart from that, we have been suggested that for detailed geological and geotechnical, especially the geotechnical investigation, because we haven't any real means lab data for analysis. So we have suggested that there is a means geotechnical study of that material of that slide for analyzing real and actual cause. Apart from that, we have also worked out for the possibility of tunneling to avoid or to pass out the that affected zone or slide. So we have seen that there is a possibility, but some problem, especially the lateral cover of rock mass on that tunnel. But there is a enough vertical cover, but we haven't getting lateral cover in that some particular stretches, but we can exercise more and more, and we can reach some good result after doing the detailed study of that or detailed investigation of that.